Hi, this is Halal. In this video on Mathematical Economics series, we will learn about compensating variation and equivalent variation in economics. This question was asked by a brother in comment section of the YouTube channel Econ Maths. Okay, so let me write the compensating variation first. We will solve for compensating variation. Now, what is meant by compensating variation? It means the adjustment in the income that returns the consumer to original utility after an economic change has occurred. Okay, so I will explain it with an example. Let's say we have a consumer. Okay, he is consuming good X and good Y, and price of good X is Px. Let me write it here. And price of good Y is Py. Okay, consuming these two goods gives him the utility. Let us say U1 level of utility he gets. Okay, let us say he is happy consuming X and Y with Px and Py as prices, and he is getting U1 level of utility. Okay, clear? Now let us see what happens if price of X increases to Px hat. Okay, we assume here, let us say price of good X has increased to Px hat. Okay, so with Px hat and Py, let us say consumer is getting U2 level of utility. Obviously he will not be happy because price of X has increased. Okay, now compensating variation. What does compensating variation tell us? It tells us after price of X has increased to Px hat. Okay, how much money do we need to give to consumer so that he is as happy as he was earlier. Okay, it tells us how much money do we need to give to the consumer back so that he feels as satisfied as he was earlier after the price has increased. Okay, this is the interpretation of compensating variation. Okay, so I can write it here also, but there is no space available. Okay, so let me repeat it again. Compensating variation tells us after price of X has increased to Px hat, how much money do we need to give to the consumer so that he feels as satisfied as he was earlier. Okay, now let us write an example uh, to see the more interpretation of this. Okay, let us say we have a consumer. Okay, he has a utility function. Let us say u x y is the utility function, which is equal to x to the power alpha y to the power 1 minus alpha. This is the utility function of a consumer. Let us say price of x into x plus price of y into y is equal to m. That means this is the budget constraint of the consumer. Price of x into number of units purchased of x plus price of y and number of units purchased of y should be equal to the income. Okay, now to get the compensating variation, first we need to find out the optimal values of x and y. That means we need to optimize this, optimize the utility function subject to the budget constraint. Okay, how do we optimize? We use the first order conditions. I have made number of videos on optimization. So first order condition requires that marginal utility of x upon marginal utility of y should be equal to price of x upon price of y. Simply the marginal rate of substitution, uh, the ratio of marginal utilities should be equal to the ratio of prices. Okay, now how do we get this very thing? I will not show you, I will not show here how do we get the optimal values, because it will become uh, lengthy video here. Okay, so for that we first need to differentiate partially with respect to x, then with respect to y, then divide these two marginal utilities and set them equal to the ratio of prices. Okay, so I will not show you here, but I will show you that we will get, when we solve this for optimization, we will get x star optimal values of x will be equal to alpha upon pxm If I got time, I will show you how do I get this very demand function, or how do I got this optimal value for x. Similarly for y, I will get 1 minus alpha upon py, okay, into m. Okay, that means x is a function of price of that very good into price of that very good and the income. Okay, so first we need to solve for the optimal values of x and y. Okay, after that, what we need to do, we just need to plug these very optimal values into our utility function. So u x, that is optimal value, y star is equal to, let's take these two values in this function again. So what will we get here? So in place of x we have this very thing, alpha upon px uh, into m raised power alpha. Then we have, in place of y, we have 1 minus alpha upon py into m. Okay, now if we solve this, will come out to be, it will come out to be alpha upon px, then we have 1 minus alpha py. If we take m to the power alpha, here we have 1 minus alpha as exponent, so this will become m to the power alpha into m to the power 1 minus alpha, and this comes out to be alpha px 1 minus alpha py. So here we have alpha 1 minus alpha, alpha 1 minus alpha, and we have here only m. So this is our utility when we consume x and y. Okay, now let's take a specific example. Let us say the consumer has a utility function like this. We have x to the power 1 upon 2 into y to the power 1 upon 2, a Cobb-Douglas product utility function. Let's say price of good x is $1, price of good y is also $1, okay, initially, and consumer has an income of $100. Okay, now we need to see how much utility or satisfaction the consumer initially gets. For that, we just need to give the value of x and y, okay, the optimal values of x and y. Okay, actually it is some like this. We need to maximize uh, this very utility function is equal to x to the power 1 upon 2, y to the power 1 upon 2, subject to the budget constraint. We have x plus y is equal to 100. Okay, when we solve this, we will get the optimal value of x as, since we have solved the general Cobb-Douglas production function, alpha is 1 upon 2, 1 minus alpha is 1 minus 1 upon 2, so we will get 1 upon 2 upon price of x into m. Okay, similarly for y, optimal value of y, we will get 1 upon 2 divided by price of y into m. Okay, so in place of x, I can write 1 upon 2 divided by price of x into m raised power 1 upon 2. Similarly, we have in place of y, we have 1 upon 2, 1 minus 1 upon 2 divided by price of y into m and raised power 1 minus 1 upon 2. Okay, so I'm just using this very thing here. So this will come out to be, when we solve this, it will come out to be, so 1 upon 2, 1 minus 1 upon 2, it will come out to be 1 upon 2 px, okay, raised power 1 upon 2, and we have m raised power 1 upon 2 in this case. If we expand this, similarly 1 minus 1 upon 2 will again come out to be 1 upon 2 py raised power 1 minus 1 upon 2 comes out to be 1 upon 2. Then we have m raised power 1 upon 2. And if we solve this very thing, okay, if we solve this very thing, we will get it equal to m upon 2 under root px py. Okay, so utility that the consumer is getting when the price of x is 1, price of y is 1, income of the consumer is 100. So how much utility does the consumer get? Let us try to figure it out here. Okay, so this is the utility level. Okay, when we got the optimal values of x and y. Okay, now what is the utility when price of x is equal to 1, price of y is equal to 1, and income of the consumer is $100? Okay, we just need to plug these very values in our utility, this very utility function. Okay, actually it is the indirect utility function here. So we have 100 here, so I can write 100 upon 2, price of x is 1, this is 1 into 1, so it comes out to be 100 upon 2. That means consumer is getting 50 50 utils of satisfaction when the price of x is 1, price of y is 1, and consumer has income of $100. Okay, we have solved it for price of x, price of y, and income of 100. Consumer is getting this very level of satisfaction. Okay, now how do we find the compensating variation here? Now for that, what will I do? I will just rub this out to give you a more explanation. Compensating variation is actually, compensating variation means when we have old utility at new price. Okay, this is actually compensating variation I am talking about. When we set old utility at new price, we get the compensating variation. That is the amount of money that we need to give to the consumer so that he feels as happy as he was earlier. Okay, now we have seen originally the consumer was getting this very level of utility. Okay, now we need to take this old utility. Okay, old utility is 50, and we set it equal to the new prices. Okay, so that means what happens when price of x has changed to, let us say price of x has increased to increased to 2, price of x has increased to 2, price of y has remained same, and we need to see how much money that we need to give to the consumer so that he feels as happy as he was earlier. Okay, what we did here, we just used old utility and set it equal to the new price. Okay, so when you let me solve it here if I have the space here. So what will be the utility level when price of x is 2, price of y is 1, and income of the consumer? We need to see how much income we need to give to the consumer. Okay, so for that we just need to use this very thing and put it in this very function. So we can write here in place of m we have m dash upon, now we have 2, price of x is 2 this time, and price of y is 1, should be equal to $50. Okay, now if we solve this will come out to be, so we have m hat upon, now 2 into under root 2, under root 2 is 1.41, so this will come out to be 2 into 1.41 should be equal to 50. Okay, let me write it now here. So that means m dash is equal to 50 into, if we multiply these very things, so this comes out to be 2 into 1.1, sorry, 41, and it comes out to be 141. That means consumer is getting 141, consumer needs 141 rupees, or sorry, or dollars, to get the same level of utility that he was getting earlier. Okay, to get this old utility, consumer needs $141, okay, to be as happy as he was earlier. Okay, that means how much money do we need to give to the consumer originally? So compensating variation means m dash, that it means the money that we need, uh, this very money which gives some 50 utils of certification minus original budget, that was m. So this is 141 minus 100. That means we need to give consumer 141, sorry, we need to give consumer $41, $41 to make him as happy as he was earlier. Okay, let me repeat it here again. Okay, so I hope you are getting confused here, but it is not to be confused here. How do we get the compensating variation? First, we took the original utility level, that is when the price of x was 1, price of y was 1, and the income his consumer, sorry, the consumer has income of $100. Okay, so we need to see how much utility does the consumer gets when we have this way level of price and income. So consumer was getting 50 utils of utility. Okay, now after that, what to get the compensating variation, what we do, we just set the old utility equal to the new price. Okay, old utility was 50. Now what is new price? We assume price of x increased to 2, price of y remained same, and we need to see how much money we need to give to the consumer so that he gets 50 utilities. Okay, for that we just need to put these very things in this very indirect utility function. Okay, and when we put the value of m as m here, we have 2, then price of x was 2 into 1, the price of y was 1, and when we set it equal to the old utility and solved for m, we got the value of m is equal to $141. That means we need to give the consumer, sorry, the consumer needs $141 to get as much utility as he was getting earlier. In this case, to get 50 utilities of utility, consumer will now need $141 because price of x has increased to 2. Okay, now how much money do we need to give to the consumer is simply equal to 141. That means the income that he needs when the price is increased minus the original income, that comes out to be 41. Okay, this was about the compensating variation, and I know you are getting confused. So if you have any doubts, you can ask me in the comment boxes. How do I got the value of the things, because I have skipped some steps here, like how do we get these very things. Sorry, I have not actually solved it because of the lack of the space and time. Okay, now what is meant by equivalent variation? So we need to see that very thing here also. For that, should I rub this? What will I rub here? So let me rub this very thing. Okay, now equivalent variation tells us adjustment in income that changes the consumer's utility equal to the level that would occur if the event had happened. And how do we interpret it here? So let us say price of x was price of x, we have price of y. With price of x and price of y, consumer was getting u1 level of utility. Okay, so he was obviously satisfied. When the price of x is increased to px hat and we have price of y is same, let us say consumer was getting u2 level of utility, and obviously he will not be happy because price has increased. Okay, now equivalent variation tells us if price of x has not changed. If price of x has not changed, how much money would I take from the consumer to make him as bad as he is right now when the price is increased? Okay, so let me write it here. If if price of x had not changed, okay, how much how much money would i would I take from consumer to make him as bad as he is after the price is increased? Okay, he's now, that means after the increase in the price. Okay, now let me rub this out also, then I can solve this very thing. So I'm just doing it for free for you people. So for I need your comments, and also I need to you to share this channel with your friends. Okay, now let us see what happens. Okay, now originally what was our utility function? Utility function was, which we got, x y was equal to, when we solved for optimal values, we got m upon 2 under root px py. That is the demand function for the consumer is given by this very thing. Okay, now let us see. Let us say price of x is $1, price of y is $1, income of the consumer is 100. Okay, now let us say price of x has changed to px hat, it has gone to $2, price of y is same 1, and m is equal to 100. Okay, two scenarios we have here. Now let us first see what happens when how much utility does the consumer get when price of x has changed to 2, price of x is equal to $2, price of y remains same, and income of the consumer is 100. Okay, how much utility does the consumer get? So just plug these very values here. So in place of m we have 100 upon 2, price of x is 2, so this is 2, price of y is 1, so this is this very thing, this is 2 under 2, 100 upon 2 under 2, it will come out to be, when we solve, this will come out to be 35.36. Okay, this is this is the utility that the consumer is getting. Okay, now originally we need to see u when price of x is equal to 1, price of y is equal to 1, and we need to see how much income do we need to take from the consumer. Okay, to make him as bad as he is when the price is increased. That means In case of equivalent variation, we solve it for new utility at old price. Okay, now new utility is this. We solve it for old price. So new utility is 35.36. This is our old price and income. Old price, and we need to see how much income do we need to take from the consumer. So let's give the values here. So we need to find m dash m hat upon 2. Price of x was 1, price of y was 1, so this is 1 into 1 should be equal to 35.36. Okay, when we solve, this will come out to be m hat is equal to 35.36 into 2. When we solve, this will come out to be 70.7. Okay, so m dash is equal to 70.7. Now we set new utility at old price, and after that we got m hat is equal to 70.7. Okay, now how much money do we need to take from the consumer? Okay, to make him as bad as he is this time. So here equivalent variation will be equal to m minus m dash. Okay, originally the consumer had $100 minus 70.7. This comes out to be 29.3. Okay, so we need to take $29.3 from the consumer so that he feels as bad as he is after the price has changed. Okay, so